Colab or GitHub. I put data notebook programs in GitHub repository, or you can find the programs through the Moodle platform. Okay, and then you can upload it to the Colab. So I told you that. And tomorrow we will have more details about the projects. So the first asynchronous sessions, I will introduce you the about the projects, and I will give you the explanations about the final project that you have to build a GitHub repository to collect the your outcomes of your learning about this winter program. And I think everyone can collaborate with the others to do the job. So this tomorrow's program, the lessons. So now we are introduce the first TensorFlow programs. I show you that the first thing is I try to give you two ideas. One is keep it simple and stupid, and one is IPO. So when you are using deep learning, the first thing is that you have to know how can you input the data. So for handwritten data, we just loaded it from tf.keras.dataset.list. So the list object has the function called the load of data, and then after load the data, we will have the 4 variables called xtrain, ytrain, xtest, ytest. So for xtrain, we have 60,000 images, which are size of 28 by 28. Then we can declare a model that using the data input of input shape by 28 by 28. So this is very important. Then we will have the second layer called the dense. So I told you that dense. So this is a flatten. And the second, you can say the Keras dense. So this is dense. So dense implement the operations output equal to activation dot input kernel plus BIOS. So it's actually it's the implementation of perceptron. I told you that before. So actually dense implement the operations of the basic neural network model. So actually the activation is the element-wise activation function passed as the activation argument. Kernel is the weight matrix created by the layer, and the BIOS is the BIOS vector created by the layer. So this is the basic layer. Actually, we are using such as full connected layers built by dense. So we check the two layers, and the dropout. And the dropout. So you can check Keras dropout. Actually, dropout is not a real dropout layer. Randomly set input units to zeros with a frequency of rate at each step. So dropout is just pass the input to output randomly, skip some of input values. So it's just transfer the value of input to output of this layer, and but skip some of the input values. So it's called the dropout layer. Actually, it will not do any computations, but just drop some input values. So this is the dropout layers, and you can check that the first layer the first the next layer. The next layer is still the dense, but however, in the previous dense we have the activation equal to G loop. So tomorrow we are I think in the asynchronous session the lecturers have introduced you the activation function, right? So if you are not clear, you can check the website. I show you that from the Keras website. So you can check here. So we have the here so we have a default. Actually, the activation function. Actually the default is none. So we are activation function. So so here so we have a different activation function. Activation function. So if we don't have assign activation function, the default is x equal to x is linear. So it means that we don't have the data. So actually input shape and output shape. Input shape, output shape. Input shape is the connection of the previous layer. The output shape is the connection to the next layer. So you have to know the input shape and the output shape. So this is the definition of dense layer, the class of dense. So this is the dense. Then, so here so we just output the dense, dense to the results. So we just skip it to the 10 outputs. So we have the 10 outputs, and we try to know the values is between 0 to 1. So actually here we are not using any activations for the next layer, but later we will have the activation functions. Then the next lines is that we will need to have two cost function that we are defined the loss function. Loss function actually is cost function that we have defined the loss. The loss is the output difference between the defined labels and our predicted labels. So this is the loss. We use the sparse categorical cross functions. And here so we are using from logits equal to true. This variable is important. I will introduce. I will give you the details about the parameters tomorrow. So then we define the loss function. And actually we need an optimizer. Here so we define the optimizer as Adams. Tomorrow I will show the optimizer and the loss function tomorrow. And then we can compare it. Yeah. So when we get the input, then we can compare the model. So I show you TensorFlow 2 have two modes. One is graph mode, one is eager mode. Now when we compile, then we compile it into a graph mode. So this is the basic model called graph model. Graph mode. So then we define the loss function. Then we compile it. Then after the compile, over the compile, we have a graph of deep learning. That you will build the computation of neural network graph. I told you that neural network graph actually is the connections of perceptrons that we will collect the values from the previous layer to the summation of layer input values with a weight and a threshold. So this is the input. Then this is a model built. Then we can do the training and the inference. So doing the training, so we have the for function model.compile is build a graph. Then we can do the model.fit. Now .fit you can see that we use the X train and the Y train to train the model. And we have an important parameter called the apples. epochs means that I told you that we will do a backpropagation to update the values of parameters. So epochs equals to 5. It means that we will do the backpropagations for 5 times of all the inputs. So when we all input the inputs, then we will update the parameters. So actually, we will have 50,000 images. So the values may be input 1,000 times. So we will have and update the parameters several 1,000 times. So this is a fit. A fit is actually training a model. Also, using a Keras, I tell you that we are using TensorFlow.Keras. So model is a class of TF.Keras. Then model.Compile is built a TensorFlow graph. Then model.Fit is training the weight and the ratio of the parameters of the graph. Is the fit. Then we have a well-trained model. Then we can use it to predict our new images. The images. So then we can do the images. So here we try to do the operations of fit, predict, and evaluate. So you must know that for using Keras, TensorFlow 2.0 version 2 to using TensorFlow version 2, you have to remember that you have 4 things to do. One is compile, one is fit, one is predict, one is evaluate. So I just do it for you. So now we have do it. Then we have compile it. Then we just fit. Here I do apples, 10 apples. So after 10 apples, actually you can continue to run 10 apples. But however, you cannot continue to run the training for too many apples. If you run too many apples, you will meet common problems called overfitting problem. And then I will tell you, hey, maybe one lecturer have a step about the overfitting problem. Then we have around 10 apples. Then we can evaluate our models by the 10,000 test data set. So here we have got the 0.9798 accuracy. It means that during the 10,000 images, we will have 10,000. So we have 202 images are classified into erroneous class. So erroneous class. So this is the deep learning models. So after sorry. So after our model that evaluate, we can use it to test our images. So here I put image here, so you can find I have a test image called the digital 4. So you can check it. So it's a very tiny image. Here I show you. Tiny image. So now I upload the image image into the force. So here you can see that I have a very tiny image called the digital 4. Digital 4. Digital 4. I upload an image called digital 4. Then I try to recognize to do the recognition of this image, which digit is in this image. So this is written by me, and I will try to write image later. Then here's I will try to load the images. So here's also here I try to read the image. So here's I from PIL. PIL is the Python image library. Import image. Then I can and I can display from IPython display. From IPython that display. Import display. Then I can read the images. Image equal to image dot open. So we have the image called the digital 4. Digital 4 dot BMP. .bmp. It's a bitmap 4. Then I can display it. I just display the image. So I just try to display it. Hey, sorry, digital 4 dot image. Sorry. Digital 4 dot image. Hey, display. Image. Sorry, image. So you can find that we have image 4. Then we can try to use the model to recognize it. So here's I'm trying to recognize these images. So by first, this is the bitmap image. So I have to reshape it as the list format. So I need to use the import numpy as np, and I have to reshape it into the 28 by 28. If your image is not 28 by 28, if you can use any size of images. But however, I told you that you have to resize to keep your mind that you have know how can you input the data into a deep learning model. So here we have the model. We have the model training by needs the data set. So it's the 28 by 28. The input is 28 by 28. Then we have to convert it into an array. So by im2 dot array by np dot array image. So it will convert the bitmap into an array. An array, then I need to reshape it into the models. So we have the im2 array reshape. So here's I'm doing the reshape. Reshape. Shape to 1. Because the first parameter 1 is because we have it means that we just have 1 images. So you have to know in the training data set we have so many 60,000. So here we have to give him just 1 images for him to do the predictions. So here we have to know if we are trying to do the tests, we have to input the data first. Then we can do the predictions. Why? You have to know when you're using deep learning, the model are doing can read just the tensors. So here we are doing the model dot predict. So here we are model dot predict. Predict these images. So we have the images. Then we print the result. I print. Oh, sorry. PINT. So you can see that we have the values of the outputs. Then this is 1, 2, 3, 4. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can find that the biggest value is 4. So the value that, and we will do the argument max. So the prediction y number y head for 2 np dot argument max this is y argument max y predict. So you can trigger the y head. Y is a predictor output. So you can trigger that the value the image the bitmap image for is predicted as 4. So you can find that our deep learning model actually can recognize this image as a digit handwritten image as 4. And now I open the drawer of Windows.小画家. So I don't know if you can check to the. However, my Windows is in Chinese, so I have to use the drawer called the painter. Okay. So I have the painter. So I loaded the images. So I loaded the image download. Yes, I try to find images at that time. Here, upload. Here's my image here. Yeah. So I open the digital n .bmp. So you can find it's a small image. So however, you can open it. You can just zoom in. Zoom in. I use the zoom in. I use the zoom in. Then I zoom in. Then I try to draw. Draw a strange handwritten words, such as I just do it this one. And how can you guess? This handwritten digits. What kind of number? What number our model will infer this image. Our model which number our model will infer. So I just save it. I just save it as a digital X. There is a X. So this is digital Y, digital Y, digital Y. So then you can try to give your digits, handwritten digits. Then I upload my digital Y as change a digit such as a digit Y. So I open it. Then this is a notebook, so I can read it again by just modify the input file. Then I get the file. Why? So you can see that I have a strange digits, handwritten digits. Then I read it again and convert it into an array. Then I just try to predict it. So you can find that the biggest number is still the 4. So actually this one is also and 3. This is one. This image is determined as predicted as number 3. So you can try to output bitmap images and try to infer by your model. So I think it's a interesting thing for you to test what is deep learning models. So this is today's the second part of today's hands-on program. So you can check the program. However, I just give you the last part in I will give you in the chat room. So now we will have a 5 minutes break. Then we will have the third part of today's lesson. So now I give you the we have a 5 minutes break to 60 35. Right. So we have a 5 minutes break.